Right. So let us try some 2 more questions. Question number 1. 2 electric bulbs P and Q have their resistances in the ratio of 1:2. They are connected in series across a battery. Find the ratio of power dissipated in these bulbs. Right. See, 2 bulbs are connected in series across a cell. Right. We know we have only one single current possible in this circuit, series combination, which is I. Bulb P and Q have their resistances R1. Resistance of this one is R1. This has a resistance R2. Then question says R1 by R2 is equal to 1 by 2. As per the question, 1:2 is the ratio. Now, when they are connected in across a battery, find the ratio of the power dissipation in these 2 bulbs. How will you find the power dissipation? See, power in the first one is P1, in the second one it is P2. Okay, see, we can say power P is equal, we have the equation for power P is equal to I square into R, or it is V square by R, or it can be even V into I. Okay. Yes, so we know potential across bulbs, 2 bulbs will be different. See, total sum of the 2 will be the total potential applied. But current is same for both. So let me prefer this equation, I square R. Okay, so power in the first one, P1 is going to be I1 square R1 square, right? P2 is going to be I2 square R2 square. But I1 and I2 will be the same because series combination, no. So same current will be flowing through them. Yes, so if you take the ratio, we are asked to find out what is power in 1 to power in 2, the ratio P1 by P2. So we have to take the ratio. What is P1 by P2? P1 by P2, I1 by I2 gets cancelled each other because I1 and I2 are equal, into R1 by R2 the whole square, R1 square by R2 square. See, I1 and I2 gets cancelled. I1 is equal to I2. In series combination, we know I1 is equal to I2. So what is P1 by P2 ratio finally? R1 by R2 the whole square. R1 by R2 the whole square is actually 1 by 2 the whole square. We got 1 by 4. That is the ratio of power dissipation in the bulbs when they are connected in series. Okay, moving on. Question number 3. An alpha particle proton and proton of the same kinetic energy are in turn allowed to pass through a magnetic field B acting normal to the direction of motion of the particles. Okay, calculate the ratio of radii of the circular paths described by them. See, we know expression for radius of the circular path when charge enters normal to the magnetic field, case 2, right? Theta was 0, case 1, case 2, theta is 90 degree. In that case, we know the charged particle undergo circular motion. So, radius of that circular motion is going to be mv divided by qb. See, that was the equation, the basic form of the equation. Then this could be like, this is momentum, right? Linear momentum by qb. Linear momentum and kinetic energy are related like root of 2m into kinetic energy, right? 2me. E is the kinetic energy. Okay, don't be confused. This is Ek then. Ek is the kinetic energy divided by qb because momentum and kinetic energy are related by these equations. Another form of the same equation was R is equal to root of 2m. Kinetic energy of any charged particle was q into v divided by qb. So these are the 3 or 4 different forms of the same equation. Whenever we get questions from this part, like charge enters a magnetic field, normally, pick the equation by reading the question properly. Just check once again, you are given same kinetic energy. Both the particles, alpha particle and proton, both of them have same kinetic energy. So select the equation in which kinetic energy is coming. You can take any equations, but this will be easier, right? And you cannot proceed with the other equations if you don't know kinetic energy where to substitute. That is only information given. Yes, so we go for that equation. R is equal to root of 2m kinetic energy divided by q into b. Look at this equation. 2 is a numerical constant. M is mass of the charged particle. We have 2 particles entering, alpha particle and proton. They have different mass, so mass is not a constant. But question says kinetic energy is the same for both. 2 is a constant. See, charge of alpha particle and proton, they are not the same, right? We know. But they enters the same magnetic field. So in this equation, 2E and B remains the same for both the particles. So we can simplify this equation into a relation like root m divided by q. Correct? R is proportional to. Since we have to find out only the ratio, we can use this relation. Yes, root m by q. So radius of alpha particle is going to be proportional to root of mass of alpha by charge of alpha, and that of proton is proportional to what? Root of mass of proton by charge of proton, because it is proportional to root of m by q. Now take the ratio. We can go to the ratio R1 is to R2, or R alpha is to R proton is equal to root of mass alpha by charge alpha is to root of mass proton by charge of proton. We know their values, right? Mass of alpha. What is mass of alpha? We have 4 particles inside, right? You remember the table? 4 atomic mass unit, right? And what about the charge? Charge of alpha, 2e, right? 2e. And for proton, mass of proton is just 1u, one single particle, and charge of proton is just e. Substitute those values. Rp is to R alpha is to Rp equals to root of 4u divided by charge of alpha is going to be 2e is to root of mass of proton is going to be just u divided by e. So what could be the ratio? You can cancel e from these ratios. You can cancel root of u from both, correct? So we get root of 4, yes, is going to be 2. 2 and 2 gets cancelled. Nothing is the remaining here, so we get the ratio 1 is to 1, correct? Root of 4 by 2, 2 by 2 is 1. U and E already cancelled. So 1 is to 1 was the ratio. So select the appropriate equation and substitute the required values based on the particles. Okay. Question number 4. A similar question. This time particles are different. Deuteron and alpha particle. Deuteron and alpha particle. And the situation is also different. They have same momentum, not same kinetic energy. They have same momentum, are in turn allowed to pass through the magnetic field B, acting on the remaining part is the same. Okay, they are entering normal to the magnetic field. You are asked to find out ratio of the radius of the circular path. I am taking you back to the equations. This time, since they are talking about momentum, we have to consider the equation for radius of the circular path. Momentum divided by QB, right? R is equal to P divided by Q. P divided by QB. Now look at this. You are given same momentum for both. So P and they enter the same magnetic field also. So B also remains the same for both the particles. So what about radius? Radius is directly proportional to reciprocal of Q. So R deuteron is to R alpha. Yes. So R deuteron is to R alpha could be what is 1 by charge of deuteron is to 1 by charge of alpha. Correct? Substitute. What about charge of deuteron? Deuteron, we know it is a combination of a proton and a neutron, right? But proton only has charge, so it is E. 1 by E is 2. What is charge of alpha? Charge of alpha is going to be 2E. So 1 by E is to 1 by 2E. So what about this? E gets cancelled. We get 1 is to 1 by 2. Or it is going to be 2 is to 1. That's the ratio. Okay. Yeah. A similar question. We just used the other equation because this time momentum was the same. Good. Now, question number 5. Two bulbs are rated P1V and P2V. P1 is the power of the first bulb at a potential V, and P2 is the power of the second bulb at a potential V. If they are connected in series and in parallel across a supply voltage V. See, these are rated at a constant voltage, V. This is also the rating given at the voltage V. And we are going to connect them across the same potential, same rating voltage only, but in parallel and series also. Find the power dissipated in two combinations in terms of P1 and P2. Okay, we have to find out power in series and parallel combination in terms of power of these two bulbs, P1 and P2. Yes. See, we have power. We are given power and potential difference. See, how can we relate this power and potential difference? P is equal to V square by R. So, what could be R from this? Resistance. V square by P, right? R is equal to V square by P. Okay, we need that equation. I am going for the first one, like series combination. In series combination, what should we do? Bulbs are connected in series, right? They are connected in series. So, the first bulb will have a resistance R1, second one will have a resistance R2. How will you find out the equivalent resistance of the combination? R equivalent is going to be R1 plus R2 only. Yes. See, the R equivalent of the combination is going to be equal to V square by pressure equivalent of the combination. R1 will be equal to V square by pressure of the first bulb. I am sorry, power of the first bulb. R2 is going to be V square by power of the second bulb. Okay. Yes. So, we are going to substitute like that only. R equivalent is going to be what? V square divided by the total power in the series combination is equal to R1. What will be R1? V square by power of the first bulb. V square by P1 plus V square by P2. Okay. See, V square, V square, V square. We can cancel them. So, what is the reciprocal of power? 1 by P is equal to 1 by P1 plus 1 by P2. So, the power in series combination, P is related to 1 by P1, I mean P1 and P2 as you can see in this equation. If you want, you can simplify further. 1 by P is going to be P1 P2 divided by P1 plus P2. Correct? So, that will be the final answer, or you are asked to just find out the expression in terms of P1 and P2. This is fine. Okay. Now, in parallel, what can we do? In parallel combination, what will be the result? What will be the equation when we connect them in parallel combination? See, we have 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Yes. So, how will you substitute R equivalent? V square by P equivalent, right? So, if it is 1 by R equivalent, I will write reciprocal of that P equivalent by V square is equal to, what will be R1? R1 is going to be V square by P1. So, it is going to be P1 by V square plus P2, right, by V square. Got it? So, what about V? V can be cancelled from this side also. We get P is equal to P1 plus P2. That is the power, total power in parallel combination when they are connected parallel in terms of individual power P1 and P2. So, you are asked to find out only these expressions. So, we got it. Okay. Question number 6. A charged particle Q is moving in the presence of a magnetic field B which is inclined at an angle 30 degree. Yes, angle 30 degree. Case 3, right? Case 1, theta is equal to 0 or 180, it go undeflected. Case 2, theta is equal to 90 degree, particle go along the circular path. Case 3, any other angle other than 0, 180 and 90. 30 is coming in the third part. Yes. With the direction of the motion of the particle. Okay. Draw the trajectory followed by the particle in the presence of the field and explain how the particle describes this path. Okay. What will be the shape of the path? You must have identified by the time. It is a helical path, right? So, if you have an magnetic field, uniform magnetic field present in this region, B, and into that magnetic field, a charge enters by making an angle 30 degree with the direction of electric field, right? So, this angle was given as 30 degree, velocity and magnetic field 30 degree along the direction of the magnetic field. Then, what will be the path followed by this? We know if it is theta is equal to 0, I told you undeflected straight line path, theta 90 circular path. If theta is any other angle other than 0, 180 and 90, it will follow a helical path, right? It will go helically like this. Yes. So that is the shape of the path. And why? You're asked to explain how the particle describes this path. See, we know that velocity, see, electric field and the velocity was in this direction. This was the direction of velocity, right? That velocity we resolved into two components. One is along the magnetic field, that is V parallel. If this angle is 30 degree, this will be V cos 30 degree. And the other component is V sin 30 degree. Yes, sin 30 degree, right? Yes. Then, why does it follow the like helical path? Because the V cos 30 component, right? V cos 30 component will lead the particle undeflected, because the direction of velocity is along the direction of the magnetic field. That is case 1, theta is equal to 0, no force acting. So it's supposed to go undeflected. At the same time, V sin 30 component will be forcing this charge to undergo circular path. Why? Because that velocity was perpendicular to the magnetic field. Second case, theta is equal to 90. So this is a combination of, third case is a combination of first and second, right? So combination of undeflected and circular path will be a helical path. That is how we explained it. Okay, hope you remember. Question number 6. Right? Now, moving on to the 7th one. Okay, the space between plates of a parallel plate capacitor is completely filled with two ways. In the first case, it is filled with a slab of dielectric constant K, completely filled with one single dielectric constant. Yes, in the second case, it is filled with two slabs of equal thickness and dielectric constant K1 and K2. Yes, see, divided at the center and divided, filled with two different dielectric materials. The capacitance of the capacitor is same in the two cases. Obtain relationship between K, K1 and K2. You're given that this is the capacitor 1, C1. This is the capacitor 2, C2 suppose. C1 is equal to C2. Given that C1 is equal to C2. If so, how can you relate K, K1 and K2 is a question. We know how to solve, right? We have done these kind of questions. This is one completely filled capacitor. This is also completely filled but with two different dielectric materials. We will consider this capacitor as a combination of, series combination of, end-to-end combination of two capacitors, CA and CB. So what could be C2? C2 is going to be equal to CA, CB, series combination, equivalent. Yeah, so we will find out expression for C1, then C2 using this technique, we'll equate them. We'll get the relation between K, K1 and K2. Let us do it fast. First case, we can find out C1 here itself. See, C1 is going to be equal to epsilon 0 A divided by D, right? That is the expression for capacitance of a parallel plate capacitor. Yes, and it is filled with dielectric material. So there should be a K also. K epsilon 0 A by D. Yes, equation number 1. C1 is ready here. Right? We have to find out C2. What did I tell you? C2 is a combination of two capacitors connected in series. So we can say 1 by C2, equivalent of two series combinations, 1 by C2 is going to be equal to 1 by CA plus 1 by CB. Because CA is the first capacitor, CB is the second capacitor. They are filled with different dielectric materials. Combination, series combination of the two will give you C2, effective C2. And when we consider CA, remember plate area will be A, but distance between the plate is D by 2. When you consider CB, plate area will be A, the whole plate is available, but plate area is available, but the distance between the two will be D by 2 only. So if you write equation for CA and CB, substitute here, you will get C2, then C2 is equated to C1, then we will get a relation between K, K1 and K2. Let's proceed. First one, C2 is to be calculated. 1 by C2 is equal to 1 by CA plus 1 by CB. See, can you quickly tell me what is CA and CB? CA, let me write it here. CA is going to be epsilon 0 A divided by D only. But there is a difference. It is filled with dielectric constant K1 and distance is not D, it is D by 2, correct? D by 2. So CA is going to be 2 comes up, 2K1 epsilon 0 A divided by D. What could be CB in the same way? CB is going to be same 2 but K2, right? Another dielectric constant, epsilon 0 A divided by D. So we have the values of CA and CB. Let us just substitute there in this equation. What will we get? 1 by C2 is equal to 1 by CA, CA reciprocal. So we have to take D divided by, we get D divided by 2K1 epsilon 0 A because it is 1 by CA, okay? And D divided by 2K2 epsilon 0 A, that is going to be 1 by C2. So if you take D divided by 2 epsilon 0 A common, we have only 1 by K1 plus 1 by K2 here. You can simplify that further. So D divided by 2 epsilon 0 A into K1 K2, K1 plus K2 here, right? But that is 1 by C2. So what is C2? C2 is equal to 2 epsilon 0 A divided by D, reciprocal, right, of this equation, into K1 K2 divided by K1 plus K2. So this is your equation number 2, which is C2, correct? You were given C1 and C2 were equal. Equation number 1 gives you C1, right? C1. Now 1 and 2 are equal. We can proceed here from 1 and 2. From 1 and 2. See, given C1 is equal to C2. This is given, right? So using 1 and 2, I can equate them. So 2 epsilon 0 A divided by D into K1 K2 divided by K1 plus K2 is equal to, what was CA? C2 we wrote. Now we have to write here C1 in the RHS. What is C1? K epsilon 0 A by D. So it is going to be K epsilon 0 A divided by D. Look at that, we can cancel epsilon 0 A by D, right? What is K? K is equal to 2 times K1 K2 divided by K1 plus K2. That's a relation connecting K, K1 and K2, okay? Yes. So that was question number 7. We considered this as a series combination of two capacitors. Found resultant as C2. C1 is equated to C2. We got relation between K, K1 and K2. Okay, fine. Question number 8. N small conducting liquid droplets, each of radius r, are charged to a potential V each. These droplets coalesce to form a single large drop without any charge leakage. Find the potential of the large drop. We are going to combine so many small droplets, actually n number of small droplets, capital N, into a very big one single drop. Okay, and we are given more details about the small droplets. Each of them are charged to a potential V. So these are all of charges Q each, suppose. See, identical ones. Each of them have a charge Q, and potential of all of them will be V. Okay, what will be that V? Suppose R is the radius of each of these drops. We know potential of a charged sphere, right? V on the surface or inside, like it will be same throughout. V is equal to KQ divided by R. This is the expression for V. So this is the potential of each small droplet, each one of them, KQ by R. Fine. Now, what will be the rate, potential of this big drop when we combine all them to form a bigger one? Let me take it as V dash. Potential of the bigger one is going to be same K into capital Q divided by R. Okay, now if you can connect or replace this capital Q in terms of small q, capital R in terms of small r, we can compare V dash and V. That is your end result. No numerical values given, right? Okay, see what could be Q? Let me substitute Q. But Q, capital Q. See, we know n droplets, each of them have Q charge, are combined to form big one. So Q is going to be n times small q, correct? N times small q. Because we have n droplets, each of them have a charge Q. Because they are charged to a potential V. So total charge in this big drop without any charge leakage, there is no charge leakage when we combine them. So total charge is going to be n times charge on each capacitor, in each droplet. So capital Q is ready for substitution. How will you find out radius in terms of small r? For that, we will consider the volume, right? We know. So volume initial is equal to volume final. Volume final. In the sense, total volume of the liquid drop remains the same when we combine together also, right? What was initial volume? 4 by 3 pi r small r cube is the volume of each n drop. I mean each of the drops of small drops. There are n such drops, so that should be multiplied with n. So each drop has a volume 4 by 3 pi r cube into n. That is the total initial volume. What is the total final volume? 4 by 3 pi into capital R cube, right? Because radius of the big drop is r only. You can cancel 4 by 3 pi from either side. We need to find r. See, we got r cube is equal to what? N times small r cube. We need capital R to be substituted. If you want to substitute capital R, take the square root, cube root. So what will be r? R is equal to r cube becomes r only, but cube root of n is going to be n raised to 1 by 3. Now you can substitute r and n also, because we got r. From this calculation we got r is equal to n raised to 1 by 3 times small r. Okay, let us substitute those values. What will we get? V dash is equal to k into n small q. Okay, capital Q changes to small q into n. And r, capital R is going to be n times 1 by 3 into small r. Equation number 2. Okay, equation number 1. Okay, fine. So let us simplify this further. We can just take that n, right? So let me complete it here. V dash is equal to k into q divided by r. What are the remaining terms? Kq by r. N is there in the denominator into one more n in the denominator, which comes up as minus 1 by 3. Okay, so V dash is equal to kq by r into n raised to 1 minus 1 by 3 is going to be 2 by 3, right? N raised to 2 by 3. See, using equation number 1, what is this? Using equation number 1, it is the potential on each small drop, right? Yes, so potential of the big drop is going to be n raised to 2 by 3 into potential of each small drop. That's a relation. Okay. So it was easy, like when we combine them to form a big drop, but at that time charge will be changed, like it was q in each of them. So that charge calculation was easy because n number of charges combined to form a big drop, so n times q. Radius of the bigger drop, which is the other term in the equation, that we found out from the volume calculation, right? Yes, volume calculation. So from that volume calculation, see, this was that part. We got capital R is equal to n raised 1 by 3 times small r. So this is the relation. Okay. Question number 9. A battery of EMF 12 volt and internal resistance 4 ohm is connected to an external resistance capital R. If the current in the resistance is 0.5 ampere, calculate the value of external resistance capital R and the terminal voltage of the battery. Yes, EMF of the battery is given. Let us pick the values given first. E is equal to 12 volt. Okay, internal resistance is also given. R is 4 ohm. And external resistance is R, which we don't know, that is to be calculated. But current is given as 0.5 ampere. You are asked to find terminal potential difference and external resistance R. Okay, so how will you find it out? We have the relation V equals to E minus I into R, correct? EMF is given. Yes, what is EMF? 12 minus what is current? Current is 0.5 into internal resistance is 4. 0.5 into 4 is going to be 2. So 12 minus 2 is going to be 10 volt. That is a terminal potential difference. We got terminal potential difference. Actually, that is the second part, B, right? B we already calculated. Yes. Now, if you know part in terminal potential difference, calculation of external resistance is easy now. How will you find it out? We know terminal potential difference V is equal to current into external resistance. V is equal to I into R. We have all those values. R is equal to V divided by I. Yes, so what was V? Terminal potential difference is 10 volt. What is the current given in the question? 0.5, which is going to be 20 ohm, right? So we got both the values. Direct substitution only, easily we calculated. Okay, question number 10. The number densities of free electrons in three conductors X, Y and Z are in the ratio 4:1:8. And their electrical conductivities are in the ratio 2:1:2. For which conductor will the relaxation time of free electrons be maximum and minimum? Yes, relaxation time is to be calculated. Tau. You are given the ratio of number densities. Yes, number densities small n. And another quantity given is, what is the next ratio? Conductivities, electrical conductivities. That is sigma ratio. Right? Sigma ratio is given. Sigma is electrical conductivity, right? Yes, which is equal to reciprocal of resistivity. Okay, so if you know relation connecting torque, number of free electrons or free electrons density, sigma or rho, you can solve this question easily. Yes, see, we had expression for like resistivity, right? You remember resistance R and resistivity rho we found in terms of like relaxation time, right? So we got what was the equation for resistance. From that we can easily get expression for resistivity. So the we got it like V is equal to I into R from Ohm's law, and I we are going to write in terms of drift velocity, right? So we know I is equal to V is equal to NAE into drift velocity into R, correct? So what was drift velocity? NAE into EV divided by ML into tau into R. So we can cancel now this V from either side. Both V's are cancelled. So what is R finally? R is equal to ML will come to the denominator divided by NA E into E becomes E square tau, right? This was the equation for resistance. Then how will you make it resistivity? Rho, which is equal to R by R A by L, right? Rho is equal to R A by L because R is equal to rho L by A. So here R into A by L. So we have to just cancel A and L from this, right? We can write, one second. See, resistivity is going to be, resistance is going to be rho L by A is going to be equal to ML by NAE square tau. So finally, we got this equation as rho L and A gets cancelled. We got rho equals to, what is rho? M divided by N into E square tau. This is the relaxation time resistivity relation. Relaxation time resistivity relation. So resistivity, reciprocal of that is going to be conductivity. So what is sigma from this? Conductivity. N E square tau divided by M. This is the relation connecting them. Yes. If you remember this equation, you can just take the reciprocal directly, you can proceed. See, this is the conductivity. Sigma is equal to 1 by rho. Now, you're asked to find out what is the relaxation time. See, how will you find out relaxation time using this equation? Relaxation time using this equation is going to be equal to sigma times M, okay, sigma M divided by what? N E square into sigma M divided by N E square only. That is the equation for relaxation time in terms of sigma and number densities. See, look at that. We are given like M, mass of electron, is a constant. E is charge of electron, another constant. Relaxation time is proportional to sigma by N. Yes. That is a ratio, or that is a relation we can use to find out maximum and minimum relaxation time. So let us check X, Y and Z. What about relaxation time of X? Relaxation time of X is proportional to, what is the sigma ratio? Which one is the sigma ratio? This one, right? Second one. So we have electrical conductivity ratio 2. Okay, so we can take 2 divided by, what is the number density? 4, right? Number density for the first one is 4. So we can get proportional to 2 by 4. What is tau of y? Second one is proportional to 1 divided by, the other one is also 1. Yes. And what about z? See, sigma by n ratio. Sigma is going to be 2. And what is the n ratio? It is going to be 8. So in this one, we can find out this is going to be proportional to, torque is proportional to 1 by 2. Torque is proportional to 1. Torque is proportional to 1 by 4. Yes. So which is the maximum? Maximum is for y and minimum is for z, right? So these are the two options we have to find out maximum and minimum. So out of this, maximum relaxation time is for the material y, conductor y, and minimum is for conductor z as per the ratio. Okay, so the question was based on the relaxation time resistivity ratio. Instead of resistivity, they have given the conductivity, reciprocal of resistivity. Okay, yes. Question number 11. A wire of length L0 has a resistance R0. It is gradually stretched till its length becomes 2L0. Plot a graph showing the variation of its resistance R with its length L during the stretching. Okay, what will be its resistance when its length becomes 2L0? See, the question is based on whenever a conductor is stretched to another length, like we have a conductor of length R1, length L1, which has a resistance R1, right? Length L1. See, resistance R2 when its length is L2. Then how will we relate these two? We had a derivation, right, for that R1 by R2 equation. So that is R1 by R2 is equal to L1 by L2 the whole square. Remember, we have to stretch the wire to another length. We are not going to connect another length and increasing the length. No, we are going to stretch a wire to another length from L1 to L2. So R1 by R2 is equal to L1 by L2 the whole square. You are given initial length as L0. So, and that at that time it is R0. We can say R0 divided by R. R is to be calculated, R2, okay, is equal to L0 divided by, what is the new length? 2L0, the whole square. So L0 gets cancelled. We get R0 by R is equal to 1 by 4. So what is new R? The new resistance R is equal to, cross multiply, we get 4 times R0. This was the equation. Okay, this was the final resistance after stretching into 2L0. Okay, so we have solved the second part first, like B part we already solved because we had the equation directly. So that part we have solved. A part is to plot a graph showing this variation. See, if you draw a graph, see, if I take, this is my x-axis, suppose, okay, and I have a y-axis too here. This is my y-axis. Fine, I am going to take resistance along this and length along the other one. So we changed the length from L0 to 2L0, right? So this may be 0, this is L0, and this is 2L0, and this is 3L0, and so on. And on this side, we have R0, 2R0, 3R0, 4R0, and so on. Suppose that is how the value changes. Okay, then what about the given value? When it was L0, when the length was L0, look at this, the value was R0, right? Initial resistance is R0. We found out when the length is 2L0, resistance is 4 times R0. So when it is 2L0, what is the resistance? It becomes 4R0. So these are the 2 points, initial and final values of the resistance during the change. And how should I draw the graph? Should it be a straight line like this? No, because look at this, resistance is proportional to L square, correct? L square. So the graph is parabolic, so it should go like this. Okay, that is the way how the resistance vary. So we found out initial resistance and final resistance. Initial was given, final we found out when the distance is 2L0. Based on that, we draw the graph. That was the answer for the first question, A. Okay, right. Question number 12. Find the total charge stored in the network of capacitors connected between A and B as shown in the figure. A combination of capacitor is given. See, this we can simplify further. That will be easier to solve then. We have 4 microfarad and 2 microfarad, 6 and 3 here. So between A and B, see, this is the point A, suppose. See, 4 microfarad and 6 microfarad are connected in parallel, right, across each other, parallel. Yes, that is one combination. From there, we have one more combination. 2 microfarad and 3 microfarad are connected in parallel. See, this is how this can be simplified. So I will write the values of those capacitors. This was 6 microfarad. This is 4 microfarad, 2 microfarad, and this will be 3 microfarad. Okay, now it's easy. What about these two combinations? Between A and B, this is the point A, okay? Between A and B, let me take a point here, which is C, suppose. Between A and C, what is the equivalent of the two? Equivalent of the two between A and C is 4 and 6. Parallel combination, sum of the two capacitors. It is going to be 6 plus 4 is 10 microfarad, right? And this was the point C. Now what about these two? 3 plus 2 is going to be 5 microfarad. 5 microfarad. This is the point B. This was C, this was A. Now look at that. Between A and B, we have two capacitors in series. So what is the effective equivalent capacitance? 1 by C equivalent is equal to 1 by C1 plus 1 by C2, which is 1 by 10 plus 1 by 5. Okay. So if you take 10 as LCM, we get 1 plus 2. So C equivalent of the combination is going to be 10 by 3 microfarad. That is the equivalent capacitance of the combination. Now look at this. You're asked to find out the total charge stored only. Okay, total charge is to be calculated. How will you find out total charge? Total charge is going to be equal to C into V, right? Q is equal to C into V. Which C? The equivalent capacitance into the voltage. Voltage applied was given in the diagram, it is 3 volt. C equivalent we calculated now, which is 10 by 3. So we can multiply 10 by 3 is the equivalent capacitance. Remember that is in microfarad. So into 10 raised to minus 6 into, what is the voltage given? 3 into 3. So 3 and gets cancelled. We get 10 into 10 raised to minus 6. 10 into 10 raised to minus 6 coulomb, or total charge is 10 microcoulomb. Okay, so we simplified that network into a smaller, like a more convenient network, and we found C equivalent first of all, using what we can find out total charge stored. Okay, that was question number 12. Question number 14. You are given 3 capacitors of 2 microfarad, 3 microfarad and 4 microfarad respectively. Form a combination of all these capacitors. Equivalent capacitance is 13 by 3 microfarad. What is the maximum and minimum value of equivalent capacitances that can be obtained by connecting these 3 capacitors? Okay, 2 questions. I think we can start with question B, right? We know how to get maximum and minimum. When capacitors are connected in parallel, if you want to get maximum capacitance, all should be connected in parallel, because we are going to get the sum of 3 capacitors, C1 plus C2 plus C3. C equivalent is going to be C1 plus C2 plus C3. If you substitute all those values, 2 plus 3 plus 4. So we get 5 plus 4 is going to be 9 microfarad. That is the maximum possible capacitance of the combination, because we add them up in series combination. Yes, we know. Now, minimum, when will you get minimum capacitance? If you want to get minimum capacitance, we have to connect all them in series, because in series combination, we get 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3, which is 1 by 2 plus 1 by 3 plus 1 by 4. So if you take 12 as the LCM, we get 6 plus 4, 10, 10 plus C is going to be 13. 13 by 12. So C equivalent. What will be C equivalent of that combination? 12 by 13 microfarad. Okay. So that is the equivalent of the combination. So this is the maximum. Maximum possible is 9. Minimum possible is 12 by 3 microfarad. Now, what was the part 1? Question part A. We're coming back to that one. We have to get an equivalent capacitance of the combination 13 by 3. 13 by 3 microfarad. See, C equivalent should be equal to 13 by 3 microfarad. See, this could be 3 plus 4 by 3, right? 3 plus 4 by 3. We have to simplify this, 9 plus 4 is going to be 13, 13 by 3. So this is the possible fraction, which means one of the capacitors given is 3 here, that we can keep as it is. That should be added to 4 by 3. The other two, 4 and 2, that combination should give you 4 by 3. Then C, like 3 farad capacitance is connected in series with another combination. Not in series, parallel, then only we can add them up. If you want to add 3 and 4 by 3, they should be in parallel. So if I take 3 in one of the branches, this is 3 microfarad, okay? 3 microfarad. Then to that, parallel to that, we are going to connect the other two. Which are the other two capacitors? 4 and 2 microfarad each. So 4 and 2 microfarad each. So let us check this combination. 4 microfarad and 2 microfarad. See, what is the equivalent of 4 and 2? 1 by C12 is equal to these two. I am going to simplify. 1 by 4 plus 1 by 2. So what is it? 4 and 3. Correct? So C12 is going to be 4 by 3. Good. As expected, C12 is what? 4 by 3 only. Now 3 microfarad plus 4 by 3 will give you what? 13 by 3. So this is the combination. You have to connect 3 microfarad parallel to the series combination of 4 and 2. Okay. Then you will get 13 microfarad capacitance. Okay. Question number 15. Derive expression for torque acting on an electric dipole when it is held in a uniform electric field. Identify the orientations of the dipole in the electric field which attains stable equilibrium. We know this part, I am not going for the derivation. We will get expression for torque is equal to P E sine theta, right? We derived this. We can just go through the notes. So this derivation is available there. And what is the second part of the question? Identify the stable equilibrium. We know stable equilibrium is when we get theta is equal to 0 degree. Right? For sine theta will be 1 and we get, sine theta will be 0, we get 0 torque. Torque is attained 0 at two different orientations, theta is equal to 0 and theta is equal to 180. Theta is equal to 0 is called stable equilibrium, theta is equal to 180 is called unstable equilibrium. So you are asked to identify only the stable equilibrium, that for that it is 0, right? Theta is equal to 0. Okay? Right. Then question number 16. The terminal potential difference of a cell is 19 volt when a current 1 ampere flows through in the circuit. It reduces to 17 volt when the current supplied by the cell is 3 ampere. Find EMF and internal resistance of the cell. Okay, you are given two different combinations. First one, terminal potential difference is 19 volt when the current is 1 ampere. For that combination, using the equation V is equal to E minus IR, we can write 19 is equal to, we don't know what is E to be calculated. Current is given as 1 ampere, so 1 into R, right? Equation number 1. Okay, now check the second combination. Same potential difference is 17 volt when the current was 3 ampere. Okay, so we can write one more equation using the same V is equal to E minus IR, that is 17 is equal to E minus 3R, right? Equation number 2. Because when the current was 3, it is 17. Now, what happens if you subtract one from the other? Equation number 1 minus equation number 2. We get 19 minus 7 is going to be 2. E and E gets cancelled, 0. Minus R, minus of minus 3R becomes 2R, right? So 2 and 2 gets cancelled. What is the internal resistance of the cell? 1 ohm. That we got directly. Yes, and if you want to calculate EMF, see, internal resistance we already calculated. We have to find EMF also. EMF of the cell can be calculated using the any one of these two equations, 1 or 2. So we can go for equation number 1. We substitute E minus just R. R is equal to 1 only, right? Therefore, what is E? 19 plus 1, 20 volt, right? That is the EMF of the cell. Okay? Yes, thank you.
Next is question number 17. The magnitude of electric field in Newton per Coulomb in a region varies with the distance r in meter as E equal to 10 r plus 5. By how much does the electric potential increase in moving from point at r equal to 1 meter to point at r equal to 10 meter? So increase in potential energy, initial position is 1 meter, final position is what? Increase in potential, not potential energy, increase in potential from r equal to 1 meter to r equal to 10 meter. That's a question. For that, electric field is given. So hope all of you remember the relation between electric field and potential. You know that E is equal to minus dV by dr. That means dV is equal to what? Minus E dr. This is a relation. Now we need potential. From where to where? 1 to r. This is dV, small potential. So how do we find the potential difference from r equal to 1 meter to 10 meter? We need to integrate. So integral dV equal to minus of integral what? E dr. But what are the limits? It is from 1 meter to 10 meter. Okay, integral dV is V. That we need to find. Increase in potential. Okay, so minus of integral, what is E value? 10r plus 5 dr. So integrating we get minus of, what is integral? 10r dr, 10 into r dr is r square by 2. So 10r square by 2 plus integral 5 dr is 5r. So what is the result? Minus of 10r square by 2 means 5r square plus 5r within the limit 1 to 10. Now we can apply the limit. V is equal to minus of, first I will be applying upper limit. Upper limit is 10. R is 10 means 10 square 100, 500 plus what? 5r, 5 into 10 is 50. Minus lower limit. What is the lower limit? 1. So 5 plus 5, 10. Okay, so we get minus of 550 minus 10, which is equal to minus 540 volt. This is the answer. This is the answer. So you please check, this is actually a direct question, but you should remember the formula E equal to minus dV by dr. Minus dV by dr formula you should remember. Okay, so the final answer is minus 540 volt. Please practice this question 1 or 2 times, it will be okay for you. Question number 18. Define drift velocity of electrons in a conductor connected across a battery. Definition of drift velocity. Hope all of you remember. It is the average velocity acquired by free electrons in a conductor when electric field is applied. Figure shows the variation of drift velocity of electrons in 2 copper wires A and B of different lengths versus the potential difference applied across their ends. So drift velocity versus potential difference. So if you are taking this as a wire of length L, potential difference is V. Okay, and this graph is showing variation of drift velocity with what does the slope of the line represent? Slope. How can you find slope of the line? Slope is equal to y by x. Along y-axis what you can see? Vd. By along x-axis what we have? V. Got it? Now what is Vd? Vd equation is, you know that EE by m into what? Tau. EE by m into tau by V. V. Okay. Now E equal to what? V by L. So we get E by m into electric field is V by L into tau. So V got cancelled. We get what? E by m into tau by L. So this, what is E by m into tau? E by m into tau is mobility. Mobility by length. So we can call it as mobility per unit length, or slope represents this quantity. You can write like this. It's perfect. First question is, what does the slope of the line represent? Slope represents E by m into tau by L. E by, if you want, you can write like E by m into tau is what? Mobility. Mobility per unit length of the wire. That's also correct. Or you can keep like this. This is what the slope represents. Now what is the second question? Which one of the 2 wires is longer? Which is having more length? So for the given potential, if you are taking which wire has got more slope, the more slope is for A. Now how slope and L are related? Slope and length are inversely proportional. Slope and here you can see what? L. They are inversely proportional. What does it mean? More the slope, smaller the length. So here they are asking which of one of the wire has longer. Longer means slope has to be what? Less. So the wire B will be longer. I hope that is clear. Understood? Yes. So B is longer because it is having less slope compared to A. Question number 19. Name the factors on which electrical conductivity of material depends. Conductivity of material depends. You know that conductivity or resistivity depends on one is what? Nature of the material and other is temperature. If they are asking conductance or resistance, apart from these two we have length of the wire and what? Area of cross section. But conductivity means it depends on what? Nature of material and temperature. Obtain the relation between current density in a conductor and the conductivity of its material. Current density. What is current density? Current per unit area, isn't it? So you know current density is represented by which letter? J. You know that J equal to what? I by A. This is the formula for current density. And conductivity is what? Sigma. They are asking us to obtain a relation. I think all of you know this. It's like a part of our direct derivation. Anyway, let me show it. We can start with Ohm's law. V is equal to what? I into R. So V is equal to I into R is rho L by A. I'm taking L to this side. So we get V by L equal to I by A into rho. What is V by L? V by L is E, electric field intensity. I by A is current density. Rho is conductivity, but we need what? Rho is resistivity, we need conductivity, that is reciprocal of conductivity, sigma. 1 by sigma. So what they are asking, what we can write? J is equal to sigma into E. This is a relation between what? Current density and conductivity. It's a very simple question. Practice it. Next, question number 20. An electric dipole with dipole moment 6 into 10 power minus 9 coulomb meter is aligned at an angle of 30 degree with the direction of a uniform electric field of magnitude 4 into 10 power 4. Calculate the magnitude of the torque acting on the electric dipole. Magnitude of the torque. This is again a simple question. Torque is equal to, you know the formula, it is Pe sin theta. Torque on an electric dipole equation is Pe sin theta. What is P? 6 into 10 to the power minus 9 into electric field strength 4 into 10 power 4 into at an angle 30. Sin 30 is 1 by 2. So we can easily solve it. 4 by 2, 2 into 6, 12 into 10 to the power minus 5. Minus 9 and 4 will become minus 5. Easy, no? Yes. What is the unit? Newton meter. Torque is Newton meter. Simple question. Don't make mistake in these type of questions. Question number 21. A point charge of 4 microcoulomb is at the center of a cubic Gaussian surface of 1 meter on edge. Find the electric flux through one of the faces of the Gaussian surface. I hope this is a familiar question for all of you. There is a cube. Okay. There is a cube like this. And where are the charges? Like charge is kept inside. Inside I am taking the charge as Q. That Q is given as what? 4 microcoulomb. What they are asking is find the electric flux through one of the face. One of the face only, not the entire cube. So here you can construct this cube as a Gaussian surface and we have the formula for flux through Gaussian surface, which is phi equal to what? 1 by epsilon naught into the net charge enclosed. Net charge enclosed is Q. But here this is the flux through the entire cube. Entire cube means through how many phases? There are 6 phases for the cube. So this is the flux through 6 phases. We need flux through one phase. I'm just naming it as phi dash. So it will be Q by 6 epsilon naught. You can substitute. Q is given as what? 4 micro. So 4 into 10 to the power minus 6 divided by 6 into epsilon naught. So 4 by 6 is 2 by 3. So 2 into 10 power minus 6 divided by 3 into, if you want you can substitute 8.85 into 10 to the power minus 12. solve this calculation part I am leaving to you. So this is the method. So please note that if Gauss flux question comes, always you have to think about the possibility of applying what? Gauss theorem. Clear or not? Yes. Next, question number 22. A closely wound circular coil of radius 6.28 centimeter, radius is 6.28 centimeter, having 50 turns, carries a steady current of 4 ampere. Find the magnetic field at the center of the coil. How will the magnitude of the magnetic field be affected if the radius of the coil is halved, keeping other factors same? Okay, so we will do the first question. Closely wound circular, radius is given, number of turns is given, current is given, magnetic field at the center of the coil. Do you remember the formula? Magnetic field due to a circular coil, applications of Biot-Savart law. In that, there is a special case field at the center. The importance of the formula, I think you know. B general equation is mu naught NIA square by 2 into A square plus R square whole raised to 3 by 2. This is a formula for magnetic field due to a circular coil. Here what is A? A is the radius and R is the distance from the center to the given point. But here in this question, they're asking magnetic field at the center of the coil only. So B equal to, for at the center, R value will be 0. So we get mu naught Ni by what? 2A. Now you can substitute. What is mu naught value? 4 pi into 10 to the power minus 7 into number of turns is 50. Current is 4 ampere divided by 2 into radius is 6.28. 6.28. 6.28. Okay, so this is pi. Here 6.28 comes means you can easily understand it is 2 pi. 2 into 3.14 is 6.28. So 2 pi into 2 pi, 4 pi. So this and this term will be completely cancelled. So 15 into 4 is 200. 200 into 10 to the power minus 7, which is equal to what? 2 into 10 to the power minus 5 Tesla. This is the expression for the magnetic field at the center of the coil. Understood? Yes. Now, what is the second question? How will the magnitude of the magnetic field be affected if the radius of the coil is halved? Radius is halved. Now you can directly move from here. If radius is halved, if I am taking it as B dash, it is mu naught Ni by 2 into, radius is half means A by 2 will come. So 2 will go up. So what we get? 2 into mu naught Ni by 2A. So it becomes how many times? 2 times. So 2 into this. So the answer will be 4 into 10 power minus 5. Easy question. So please keep the formula in your mind. Magnitude of magnetic field due to a circular coil. Okay. Question number 23 now. A long straight wire kept horizontally carries a current of 4 ampere from west to east direction. Find the direction of magnitude of magnetic field at a point 20 centimeter below the wire. So only find the direction and magnitude, both they are asking. Okay. A long straight wire is kept horizontally, carries current from west to east. So north, south, west, east, carries a current of I. At a point 20 centimeter below. So here, what is the 20 centimeter below? So first let us find the magnitude. What is the formula for magnetic field due to a straight conductor? Mu naught I by 2 pi R. So we'll substitute 4 pi into 10 power minus 7 into, what is the current? 4 ampere divided by 2 pi into 20 centimeter. So 20 into 10 power minus 2 we'll get. Pi got cancelled. 4, this 2 will be cancelled. So 10 power minus 1 will be there. Minus 1 will go up. It will be plus 1. So we get 4 into, this 2 also got cancelled, right? Minus 1 will go up plus 1. So minus 6, 4 into 10 power minus 6 Tesla. This is the magnitude. 4 into 10 power minus 6 Tesla. Easy question. Magnetic field due to a straight conductor. They are asking direction as well. Be careful. Magnetic field at a point 20 centimeter below the wire. So in your classroom, like in exam hall, you should make an idea by yourself. Here, if north is this way, south is over here. So west to east. So conductor is like this. They are asking field at a point below. Remember students, my north is on this side, my south is on this side. This is my east, I am facing east, and this is west. Current is going from west to east. So if I am applying the thumb rule, the point is below the conductor. Below the conductor, if you are applying thumb rule, you can see my closed fingers are going this way. This way means I told you that is south and this is north. So what is the direction? South to north. if this question is above the line, the closed finger is going this way, then it will be north to south, but it's below, it is from what? South to north. So 4 into 10 power minus 6, which is from south to north. Clear? Yes. Question number 24 now. Two identical circular loops P and Q, each of radius R, carrying current I are kept in perpendicular planes such that they have common center O as shown in the figure. Find the magnitude and direction of the net magnetic moment, net magnetic field at the point O. So there are two coils, right? Two coils, but they are identical in all sense. Radius is same, current is same. The only difference is that planes are perpendicular to each other. So B value will be, B magnitude will be same, you know, B equal to mu naught I by, what is the formula? Magnetic field at the center of a circular coil, mu naught Ni by 2a. But here N is 1, only one turn is there. So mu naught I by 2, what is the radius? Radius R, mu naught I by 2R. This is the field due to both the coil, B1 and B2. But what about direction? In direction, like since they are asking direction this question, there is chance of a confusion with you, like in which way? Even in this diagram itself, there is something confusing. So this direction has to be up. So you may have, as per our perspection, our view, like there is chance of getting confused, like whether it is clockwise or anti-clockwise. No need to worry about that. Here, if two planes are perpendicular, the field will also be what? Perpendicular. So whatever is your perspection, in the same way you just draw the diagram in your paper. Understood? So here it's in P, it's going like this. So I will show that B due to P is upward. And as per my view, like in this one, the second coil, the current is like this. So I can show the other magnetic field like this. If coils are perpendicular to each other, if the planes of the coils are perpendicular to each other, their magnetic fields will also be what? Perpendicular. So if this is B1 and this is B2, they are the same magnitude. So what will be the resultant field? Root of B net is equal to root of B1 square plus B2 square. But B1 and B2 are equal, so we get root 2 B1. Substitute, which is equal to root 2 into what is B1? Mu naught I by 2R. So we get B is equal to mu naught I divided by root 2R. This is the magnitude of the magnetic field at the center. Magnitude of magnetic field at the center. They are asking direction also. I told you the importance of drawing the diagram in your paper. Draw the diagram like this and you can show the vector addition concept, parallelogram law. How can you draw the resultant? Through the middle, because B1 and B2 are equal. And you can mark this angle as 45 degree. So we can show that the direction of resultant magnetic field is as shown in the figure, or at an angle of 45 degree with one of the magnetic field. Okay, so like that you can show the direction also. I hope it is clear. Let's move on to the next question. Question number 25. A long straight conductor kept along x axis carries a steady current I along positive x direction. At an instant t, a particle of mass m and charge q at point x, y moves with a velocity v along positive y direction. Find the magnitude and direction of the force on the particle due to the conductor. Question is a bit lengthy. Let's try to understand it first. Look, a long straight conductor kept along x axis. So let me take this as the x axis. So this is x dash and this is x. It carries a current I along positive x direction. So current is going like this. At an instant t, a particle of mass m and charge q at point x, y. So there is a coordinate system. Coordinates x, y moves with a velocity v along positive y direction. So let me show this as what? The positive y direction. So this is y dash and what? Y. And where is the particle? Particle is at any point x, y. If this point is x, y, you can see this distance will be equal to y. It's a y coordinate. That means that point, wherever it is at a perpendicular distance y from our straight conductor. Got it? Yes. It is, that particle is moving with a velocity v. Along which direction? Along positive y direction. So velocity is along positive y direction. So that vector concept is very important. Along positive y direction means it is velocity. How can we represent v j cap? it's along positive, and current is along positive x direction. What they're asking, find the magnitude and direction of the force on a particle due to the conductor. Force only they are asking. What is force formula on a charged particle? QVB sin theta. So first we have to find the magnetic field at that point. B, I'm going to write B is equal to, what is B? B at this point only we need to find, no? B at that point. Okay, so B at that point means it's at y distance. So we know the formula for magnetic field to a straight conductor. It is mu naught I by 2 pi r, but here r is what? Y. So look at this. This is B. B. And what is the direction of this magnetic field? If you're applying the right hand thumb rule, the point is on here xy plane. So current is going towards a positive x-axis. So you can see it is coming out. Understood or not? It's coming out means you can clearly say that it's along what? Positive z-axis. So the direction of magnetic field is along positive z-axis. So I can put what? K cap. That's the direction of magnetic field. Right. Now I'm going to write the formula. F is equal to Q into what? V cross B. What is the value of theta? Magnetic field, charge is going along y-axis and magnetic field is along z-axis, means no doubt theta is equal to 90 degree. So it is QVB is enough. Q. And V, velocity V itself, magnetic field is what? Mu naught I by what? 2 pi y, 2 pi y. But what about direction? Velocity, I told you velocity is along y direction, J, and magnetic field is along K. So J cross K is what? I cap. So what is the direction of force? It's along x-axis, along positive x-axis, because it's I cap. Now we can make a small change. QV into mu naught value is 4 pi into 10 power minus 7 into I by 2 pi into y. So pi got cancelled. So finally we get 2 into 10 power minus 7 into QVI, right, by y. This is the formula. Okay, they're asking find the magnitude and direction of the force on the particle due to the conductor. Simple. Got it? So direction, magnitude is this much, direction is along what? Positive x-axis. Clear or not? Yes. Question number 26. Two conductors made of the same material have equal length but different cross-sectional areas A1 and A2. They are connected in parallel across a cell. Show that the drift velocity of electrons in the two conductors are equal. So let's check the situation. There are two conductors of same material. Length is also same but different cross-sectional area. So if this is the first one, this is the other one. Same length but different cross-sectional areas are there. And they are connected in parallel. So these two are connected in parallel across a cell. So something like this. You know that in parallel combination, which quantity is same? Voltage will be same. So here length of this one is L, length of this one will also be L. So voltage, potential difference across both the wires will be the same. Drift velocity in two, they are asking show that the drift velocity in electrons in the two cases are equal. That's very simple. We can write the formula for drift velocity. Vd is equal to what? E by m into tau. E is equal to V by L. E by m into what? V by L into tau. This is a Vd equation. Now it is given same material. So leave it. E is charge of electron, mass of electron is same. Length is given, it is same. And since they are connected in parallel, potential will also be what? Same. So drift velocity in the first one is equal to what? Drift velocity in the other. Vd1 is equal to Vd2. This is one method, or you can use the other method, current. Using the formula I equal to NEA Vd. You'll get the same result, but this is easy. This is easy. You can just check because in parallel, which one is same? Potentially same. So we can use that idea. Okay, question number 27. A cell of EMF E and internal resistance R is connected across a variable load resistance R. Draw plots showing the variation of terminal voltage V with R, terminal potential difference with external resistance, and terminal potential difference with what? Current. Both are important questions, dear student, very important questions. So first graph is between what? Between terminal PD, and external resistance, and the second graph is between terminal PD and what? Current. So here I am going to write V and this is R. Here V and here it is what? I. We have formula V is equal to what? E minus IR. So E minus I is E by R plus R into R. So here you know that if R is equal to 0, external resistance, if capital R is equal to 0, we get V is equal to 0. So we need to start it from where? Origin. The graph should be starting from the origin. Okay. And then what is the maximum possible value of capital R? Maximum possible value of capital R is infinite. We can offer infinite resistance. If you are making R as infinity, this E by infinity will become 0. So we get V is equal to what? E. So maximum possible value of terminal PD is EMF only. So if EMF I am marking here as E, the shape of the graph will be something like this. Because you know maximum, if you are keeping like this, it means that it keep on extending. Here it become a constant. It will be at infinite resistance, EMF value will remain the same. That means terminal PD will be equal to EMF. So this is the shape of this graph. Understood? Now second graph is between what? Terminal PD and current. That's very simple. You just look at this equation. I'm writing it again. V is equal to what? E minus I R. If I equal to 0, I equal to 0 means here. What about V value? V value will be equal to E. So when I equal to 0, V will be equal to, if I am marking E here, it's the thing. Understood? Now, what is the maximum possible value of current? So I equal to E by R plus R, you know that. If external resistance is 0, then that's the maximum value of current, that is E by R. So if you are substituting that value here, we get E minus E by R into what? R. So we get what? E minus E is equal to 0. So when current is maximum, V should be what? 0. That means it should touch on x-axis. So the shape of the graph will be like this. So here we can set V is equal to 0, here I equal to 0. Two very important graphs from the chapter, current electricity. Very, very important. Can I go to the next? I think it is clear. Please practice it. Important questions. Question number 28. Consider two conducting wires A and B, both of the same diameter but made of different materials, joined in series across a battery. The number density of electrons in A is 1.5 times that in B. Find the ratio of drift velocity electrons in wire A to that of wire in B. It's an easy question. Don't make mistake. Check. Consider two conducting wires A and B of same diameter but made of different material. So this is first one. Diameter is same. Second one is also same diameter. Diameter is same, but materials. Diameter is same, but materials are different. Okay. So if you can name this as A and this as what? B. They are connected in series, dear students. If connected in series means which quantity is same? Current is same. Okay, so current in this one is equal to current in the other one. So if I am taking I1 as a current through first, I1 and I2 are equal. What is formula for current? NEAVD. So I am just writing this as N1 because materials are different. E is same, area of cross section is same. VD1 equal to N2 EA into what? V2. So EA got cancelled. We need to find drift velocity VD1 by what? VD2. That's what we need to find. VD2. VD1 by VD2 will be equal to what? N2 by N1. N2 by N1. Second one is B. So for that it is given the number density of electrons in A is 1 point times that of B. So if B is N2, no? N2 if you are taking N, then number density of electrons in A is 1 point times. So it is 1.5 times N. So what is the value? 1 by 1.5. That is the ratio of, or we can write 1 by 1.5 is 3 by 2. So the answer is equal to 2 by 3. The ratio of drift velocity will be 2 by 3. Easy question. Please don't make mistakes. So what we are doing here is, since they are connected in series, dear students, connected in series means which will be same? Current will be same. So we are just equating, it is given that same diameter. So this is very easy question for us. Diameter is same. Okay, question number 29. A long straight wire AB carries a current I. So this is a straight wire AB carries a current I. A particle of mass m and charge q moves with a velocity v parallel to the wire. This is the direction in which the particle is moving. At a distance d from it, as shown in the figure, obtain the expression for the force experienced by the particle and mention its direction. An identical question already we discussed. It is almost the same concept. Conductor is carrying what? Current I. This point is at a distance d. So surely there will be a magnetic field at that point. Let's write that magnetic field value, B equal to what? Mu naught I by 2 pi r. But here the distance is what? D. So we get mu naught I by 2 pi d. This is what? Magnitude. And what about the direction of that magnetic field? Look, the current is going up. So point is on the right side. You can apply the right hand thumb rule. It will be inward, into the plane of the point board. So the direction of magnetic field will be inward, into the planes. Exactly inward, not upward. There is a sense of a confusion. So it should be something like this. Okay, that is the direction. Obtain the expression for the force experienced by the particle. Force formula. What is force formula? QVB sin theta. What is the charge here? A particle of mass m and charge. So Q velocity is given as VB sin theta. What is theta value? It is given this charge is moving downward. Magnetic field is inward. So no doubt theta is 90. So you can substitute Q into V into B is what? Mu naught I by 2 pi d. Simplifying Q into V into mu naught is 4 pi into 10 power minus 7 divided by 2 pi into I by d. So we get 2 into 10 power minus 7 into what? Q into V into I by what? D. Everything clear now? Yes. This is a magnitude. Mentioning its direction. So they're asking, we need to mention the direction also. Simple. What is the direction of magnetic field? Inward, isn't it? Direction of magnetic field is inward and the charge is moving down. So we can easily use what? Which rule? Fleming's left hand rule. Magnetic field is in, charge particle is moving down means you can think about the current is moving down. Look at my thumb, the thumb is towards right. So what's the direction of force? Force will be towards right. Towards right. Okay, so magnitude is this much and direction is towards right. Clear? Yes. Question number 30. A potential difference V is applied across a conductor of length L and cross-sectional area A. How will the drift velocity of electrons and the current density be affected if another identical conductor of the same material were connected in series with the first conductor? Justify your answer. So check potential difference V is applied. Potential difference V is applied across a conductor of length L and area of cross-section A. So here the length is L, cross-sectional area is A. How will the drift velocity of electrons and current density be affected if another identical conductor of the same material were connected in series with the first conductor? So let us assume V is the potential across this V. So here in first case, we need to find two questions. How will the drift velocity of the electron be affected and current density be affected? So how can we find the drift velocity? Drift velocity formula we can use. Vd is equal to E by m into tau. So Vd is equal to E into, you know that E equal to V by L. So V by L and m into tau. This is the drift velocity, initial drift velocity. And what about current density? Current density is I by A. So J equal to what? I by A. If you are taking current as I. But what is I? I is, if you are taking the resistance of this wire as R, you know that I equal to what? V by R. Just I wrote it, V by R. So this is clear now. Now what they are asking is, how will the drift velocity of electron and the current density be affected if another identical conductor of the same material, material is same, identical means resistance will be same, we are connected in series with the first conductor. So the situation is changing. This is already there. One more identical is connected in series. And we are going to connect the same potential across it. Alright. So here, drift velocity, again this is a formula, E by ml. So V across this, there is no change in V, V is V itself, but length of the conductor, what is happening to the length? Length is doubled because same identical means length will be what? Doubled. So new drift velocity if you are writing, look at this, Vd dash is equal to EV by ml into tau, but length is doubled, so this will be 2L. Okay, so what is EV by ml into tau? That is the first drift velocity. So what you can see, drift velocity is halved. Drift velocity is halved. Understood or not? Yes. Now current density, new current density, I am going to write it as J dash. J dash is equal to what? I dash by A. Area is not changing, but current will be changing. How? Because there are now two resistors. So current I dash will be, I dash is equal to V by new resistance is 2R. What is V by R? I. So we get I by 2. I by 2. So we get I by 2. What is I by AJ? So this is also what? Halved. So what you can see is current density will be halved, drift velocity will also be what? Halved. So you can write it in this way. Draw a diagram and write in this way. Perfect way of writing the answer. Clear? Yes. Question number 31. A galvanometer shows a full scale deflection for current Ig. Okay, full scale deflection means you know it is a range of the galvanometer. A resistance R1 is required to convert it into a voltmeter of range 0 to V, and a resistance R2 to convert it into a voltmeter of range 0 to 2V. Find the resistance of the galvanometer. So we have to find the resistance of the galvanometer G. So hope you remember the formula for converting galvanometer into an ammeter. We need to connect a high resistance in series. That high resistance formula is R is equal to, what is it? V by Ig minus G. V by Ig minus G. Alright. This is the formula for finding the resistance R, which is needed to convert a galvanometer into an ammeter. So in first case, we need to convert to voltmeter of range what? V. For that, what is the resistance required? R1. So R1 is equal to V is V itself, V by Ig minus G. I'm going to take it as equation number 1. And in second case, we need to use a resistance R2 to make it a voltmeter of range 2V. So 2V by Ig minus G. This is the second equation. They are asking resistance of the galvanometer. So we need to find G only. So to simplify it, do one thing. Here there is V by Ig, here it is 2V. We can multiply this equation by 2. Then we can cancel that one. So what I am doing is I am multiplying this equation into 2. What we will get here? 2R1 is equal to 2V by Ig minus 2G. This is equation number 3 I am taking. Okay, right. Now if you are subtracting, you can subtract equation 2 minus equation 3. Tell me the result. LHS will become R2 minus 2R1. R2 minus 2R1. 2V by Ig minus 2V by Ig will become 0. So RHS will be minus G minus 2G. So what is minus G minus 2G? It will become plus. So 2G minus G is G. We got the result. R2 minus 2R1. Simple. This is how we can find the value of what? Resistance of the galvanometer. Easy? Yeah. We did not use any complicated idea here, just recalling the formula for how to convert galvanometer to ammeter and voltmeter. Question number 32. 3 charges are placed at the corners of an equilateral triangle of ABC of side 2 meter as shown in the figure. Calculate the electric potential energy of the system of 3 charges. My dear students, you know that this is a direct question, isn't it? Electric potential energy of a system of what? 3 charges. What is the formula? Potential energy of a system of 3 charges is 1 by 4 pi epsilon naught into Q1 Q2 by what? R12 plus Q1 Q3. It's a potential energy of a system of 3 charges, right? Divided by R13 plus Q2 Q3 by what? R23. So we can substitute. It is equal to, what is distance? It's an equilateral triangle. Distance is 2 meters. So denominator is 2. So this is 9 into 10 power 9. I'm going to take that denominator 2 also out because it is same. Q1 into Q2. We can take this as Q1, this as Q2, and this as what? Q3. Okay. And all are micro. So when you're taking the product, it will be 10 power minus 12. That also I am going to take it out. Q1 into Q2 means all are micro means will be 10 power minus 12. So we just need to multiply the numbers. Q1 into Q2 minus 4 into 4 minus 16. Then Q1 into Q3 minus 4 into minus 4 into plus 2, it will be minus 8. Minus 8. Finally what? 4 into 2, it will be plus 8. Everything clear now? Minus 4 into 4, 16 minus, and 4 into 2 minus, again 4 into 2 plus 8. Plus 8 minus 8 will be cancelled, so we can easily find the answer. Minus 16 by 2 is 8. So 9 into 10 power minus 3 is there. Plus 9 and minus 12 will become minus 3. Minus 16 by 2 is minus 8. Okay, so 72, minus 72 into what? 10 power minus 3 joules. Simple question, just matter of recalling the formula and substituting it. Okay, yes. Next question. Two identical electric dipoles are placed along the diagonals of a square ABCD of side √2 meter as shown in the figure. Obtain the magnitude and direction of the net electric field at the center of the square. So here you just leave dipole. There are 4 charges. Think like that. That will be the easiest way. There are 4 charges. We need to find what? The net magnetic field at the center. What is the side of the square? It is √2. So if this is √2 and this is √2, the diagonal will be root of √2 square plus √2 square. That means root of 2 plus 2, 4. Square root of 4 is 2. 2 is the diagonal. 2 is the diagonal means what will be this distance from here to here? 1 meter. So the distance will be 1, no? Now all are identical charges. Identical charges, but signs are different. So anyway, what will be the field magnitude due to one charge? Charge is given as Q only, right? So what we can give is E equal to 1 by 4 pi epsilon naught into Q by R square, but R is 1 square is. So we get Q by 4 pi epsilon naught. This is the magnitude of electric field due to all the charges. All the charges. Now let's check what are the directions. Be careful here. I'll be starting with this one. This one, A. This is a positive charge. So positive charge means the field will be repulsive. So this is the direction of what? E due to A. Now E due to B. This is a negative charge. So negative charge means EB direction will be this way. EB. Okay? Yes. Now again a negative charge here. So we get one more. EC will also be this way. EC. And this is again a positive charge. So ED will also be this way. Remember students, magnitude is same for all. We took the magnitude as what? E. So here EB and ED are in the same direction. So they are same means E plus E. So finally we get 2E in this direction and 2E in this direction. Right? Yes. We need to find the vector sum. How can we find? See what will be this angle. That angle will be 90 degree, no? Yes or no? Because total angle is 360, so this will be 90. So the resultant field E net is equal to what we can write? Root of 2E square plus what? 2E square. So we get E net is equal to root 2 times 2E, or 2 root 2 into E, 2 root 2 E, 2 root 2 E. What is E value? 1 by 4 pi epsilon naught into Q. Got it. This is the magnitude. What about the direction? Direction is easy now because we already got one field like this and other is like this. So the resultant will be through the middle in this direction. So direction of resultant electric field will be like that. Okay? Yes. I think this is also clear. So please practice all the questions which we are discussing here. If you feel it's a bit hard, at least 2-3 times you need to practice it. All right.